6.7 financial models. So we're going to talk a little bit about exponents and logarithms with applications and like models and stuff like that. So there are going to be a lot of formulas. Only remember what's on the review. Continuous compound theorem. The amount A after t years due to principal P invested at an annual interest rate R combined continuously is A equals P times e to the power of RT. Using continuous compounding. The amount A that results from investing a principal P of 2,000 at an annual rate R of 8% compounded continuously for time T of 1 year is blank. So how do I know I'm going to use this formula? Because it says compounded continuously. That's why. So we know we're going to be using A equals P times e to the power of RT. So it's telling us that P is 2,000. E is just E. It's like pi. Leave it as E. E is a value. We have our rate, which is R. And our R is 8%, which is 0.08. And then it gives us time of 1. So T is 1. So let's plug it in. We have A equals P, which is 2,000. Times e to the power of RT, so 0.08 times t, which is 1. And you just have to plug this into your calculator, and I will show you. So with our handy dandy calculator, we have 2,000. E, so E is second divide, that's E, to the power of 0.08 times 1. And we get our value of approximately 2,166.574135. So we get A is approximately 2,166.574135, and we round that to the nearest dollar because we're talking about money here. So we have $2,166.57. So if you put something in like a account for investing, if it invested 8% and it compounded continuously, after a year, you would have almost $2,200. So you gained $200 that year. All right, effective rate of interest theorem. So compounding n times per year, it's the rate of effective, so RE, equals 1 plus r over n to the power of n, all minus 1. And continuous compounding is e to the power of r minus 1. So suppose you want to buy a 5-year certificate of deposit, CD. You visit 3 banks to determine their CD rates. American Express offers a 2.17% annual interest compound monthly. First Internet Bank offers you 2.18% compounded quarterly, and Discover offers 2.16 compounded daily. Determine which bank is offering the best deal. The bank that offers the best deal is the one with the highest effective interest rate. So nothing in here is about continuous compound. So since that's the case, there's no continuous compounding word in here. We're going to be using rate equals 1 plus r over n to the power of n, all minus 1, because nothing in here said continuous compound. So we have 3 banks. We have American Express, and they offer a rate of 2.17%, which in decimal form is 0.0217, and it's compounded monthly. So your compounded is always your n, and monthly, there's 12 months in a year. All right, next we have First Internet Bank. I'll just put first. They're offering a 2.18%, so the rate is 2.18%, which is 0.0218, and it's compounded quarterly. So there's quarter, if you take 12 divided by 4, or excuse me, there's a quarter is 4 months, so there's 3 quarters in a year. So we have n equals 4. And last but not least, we have Discover. So Discover is offering 2.16 compounded daily. So for Discover, their rate is 2.16%, and that's 0.0216. And it's compounded daily, so there's 365 days of the year. We don't count a leap year. We just don't count it because it only happens every 4 years. So now we're going to use the formula and plug and do it 3 times. So I suggest that you do like the first 2 and then come back to the video to see them, but you should definitely try plugging this into your calculator. So our first one, American Express, we have, sorry, wrong color. So we have the effective rate in return equals 1 plus R, so 1 plus 0.0217 over n, which is 12, and that's to the power of n, which is 12, all minus 1. So I will show you how to plug this into your calculator. I will only show you the first one because everything else is the same, just different numbers. Alright, so we're going to plug in our first one. We have parentheses, 1 plus, we have a fraction, so alpha y equals enter, and 0.0217. On the bottom we have 12. Close out the parentheses, that's the power of 12, all minus 1. And we get 0.0219171308. So when we plug this in, we get 0.0219171308, which in decimal form is 2.192%. All right. Now we have to do the same thing for the rest of them, but I'm not going to show you with a calculator. So we have 1 plus our rate, which is 0.0218, over n, which is 4, and that's all to the power of n, which is 4, all minus 1. So you plug that into your calculator and you get approximately 0.0219788634, which is about 2.197%. Sorry, 198%. Alright, next we do Discover, so same thing. We have 1 plus our rate of 0.0216 over n, which is 365 to the power of n, so 365, all minus 1. We plug that into our handy dandy calculator, and we get the rate is 0.0218343157, which in decimal form is 2.183%. So the rate, if you narrow it down day to day and compare them all, the best rate is 2.198%. So First Internet Bank has the best deal. Present value formulas. Compounded n times per year, that's p equals a times 1 plus r over n to the power of negative n times t. Compounded continuously is p equals a times e to the power of negative rt. Alright, so we have a 0 coupon non-interest bearing bond that can be redeemed in 10 years for $1,000. How much should you be willing to pay for it now if you want a return of 6% compounded continuously? So compounded continuously, that means we're going to use p equals a times e to the power of negative rt. Alright, so now we're looking for how much should I fork up? How much should I put down? How much money should I put first? So we have our A, which is 1,000. E is always just E. We have time, it's 10 years. And then we have our rate of 6%. So 6%, that's 0.06. All we do is just plug it into our handy dandy formula. So we have P equals A, which is 1,000, times E to the power of negative R, so that's 0.06, times T, which is 10, Plug that into your calculator, and we get 548.81. I rounded there. We always round to the nearest cent, right? So you should put down $549, and then in 10 years, you'll get $1,000. Yeah, stuff like this is made for the wealthy people. All right, determining the time required to double or triple an investment. So how long will it take for an investment to double in value if it earns 6% compounded continuously? So we're not really even given much. We just want to know, if you have a 6% compounded continuously, how long does it take for you to double your investment? So compounded continuously, that's going to tell me A equals P times E to the power of RT. All right, so we don't know anything about money at all, but we know we're trying to double the value. So the value is the money we put down, which is P, and if I want to double it, isn't that 2P? So at the end of everything, I want to double my investment. So at the end of everything, I want to double my investment. That's what I want it to be at the end. I don't know how much money to put down. E is always E. All right, we don't know how long it's going to take, but we know the rate. The rate is 6%, so we know what the rate is 6%, which is 0.06. So we plug that in, we have 0.06, and I have no idea how long it's going to take me. That's why it's time. So do you notice how we have P's and no plus or minus? So they cancel. So we have 2 equals E to the power of 0.06t. Now, if I have an E for exponent, I need to switch this to a logarithm. So I need to switch this to a natural logarithm. So we have ln 2 over, equals 0.06t. We divide, so we divide by 0.06. And we get t is approximately 11.55. So I'll show you how to plug this into your calculator. I mean, you should already know. We've done this already. So with our calculator, we have alpha y equals enter. We have ln 2 over 0.06. And here we go. So approximately like 11 and a half years, it's going to take you about 12 years. So it will take almost 12 years to double your investment. Not worth it. All right, so part B, how long will it take to triple at this rate? So basically everything's the same, except I want to triple it now. So now for B, instead of it being 2P, because we want to triple it, A is going to be 3P, but everything else is the same. So we have 3P equals P times E to the power of 0.06t. Just as before, we cancel out the P's, because you would just divide it, and that's why they cancel. So we're left with 3 equals e to the power of 0.06t. We're going to switch it to a logarithm. Why? Because we see e as the base. So we have ln 3 equals 0.06t, divide. And we get 18.31 is about t. So it will take a little over 18 years to triple your investment.